Hello guys, I'm Alukosha Enoch and welcome to my math tutorial session on binomial expansion. Guys, this is actually the part 2 of my tutorial on binomial expansion. For you to gain a comprehensive understanding on this topic, guys, you may need to go ahead and watch a part 1 video on the same. Okay, so let's go ahead with the next question, guys. Find the value of the positive constants p and q such that in the binomial expansion of p plus qx all raised to the power of 10 and the coefficient of x raised to the power of 5 is 252 and the coefficient of x raised to the power of 3 is 6 times the coefficient of x squared. Okay, guys, you may need to recall from part 1. You know how to use the general term for binomial expansion. So let me just quickly write that for you in order to just refresh your memory on that. For example, if I have a plus b all raised to the power of n, then we have is going to give you n combination r, um, a n minus r, b raised to power r. So you can compare this now. So your a is like your p and your b is like your qx, something like that. Okay, so let's go ahead with what we have in here. Let me just complete the same here. So I have p plus q x raised to the power of 10. Guys, don't forget that what I want to do is to use the general term for binomial expansion based on coefficients. Okay, so and is this here now, for example, your n is 10 and for this very first part of the question r is 5. For this next part of the question r is 3, and for this last part of the question r is 2, and we're going to use this same here. So let's go ahead with this one here. So I have this is n combination r, so that will be 10 combination 5. So can I just, I'm going to use this one generally, so this is just like the general term. Okay, so you can just rewrite this one. I don't want to do that here, just compare. Okay, so let's just go ahead now. So let's go ahead with this one now. So this will be like 10 combination 5. Okay, so this is my a, so that is p raised to power n minus r, so that is 5 minus 5, that is 5. Then b raised to power r, so that is qx. Okay, raised to power 5. Why I need not to write qx? Because this was the coefficient of x5, so we are dealing with the coefficient. Okay, so the coefficient there is q. Okay, so q raised to power 5, that is q x raised to power 5. So we are dealing with the coefficient. Okay, so now according to the examiner this equals to 5 2. So I can calculate now what is 10 combination 5. So that is 10 shift combination 5. Wow, funny enough that is also 252. Okay, so that's it. So I have 252. Guys, because these have the same index, I can go ahead and combine pq all raised to the power of 5 equals to 52. So I can cut this one here. So finally I can end up with something like pq equals to 1, then fifth root of 1, that is 1. So pq equals to 1. Okay guys, let's just keep this one. We can call this one equation 1 if you don't mind. Yeah, let's just go ahead and call it equation 1. So this is the resulting equation from the first information given by the examiner. Okay, so now let's go ahead with this now, the same principle here. Okay, so now we have 10 combination r is 3 here, combination 3. So you can go ahead now. P raised power n minus r, that is 10 minus 3, that is 7. Then the coefficient of x5 there, that is q. So that is q raised power 3. Then equals to is 6 times. So that is 6 into 6 into. So when r is 2 this time around, so that is 10 combination 2. Okay. Then your p, just like your a here now. So p n minus r. So that is 10 minus 3. That is 7. Okay. Then coefficient of s squared q r. That is q2 s squared. Key s squared. So it's going to give you that. So that's that. So this will give us equation 2. So but let's complete equation 2 now. Let's go ahead and do this. What is 10 combination 3? 10 combination 3 is 120. So I have 120. P raised power 7. Q raised power to the power of 3. This is actually qx raised power 3, so it's the coefficient something like that of 3. So but it's the coefficient we are working with. 10 combination 2 is what? 10 combination 2 is 45. Then 45 times 6, that is 270. So 10 combination 2 times 6 is 270. 270. This one, how come I have because this is meant to be n minus r, n minus r, so 10 minus 2, this is actually 8. I'm sorry about that. Maybe it's, I don't know, my handwriting is somehow. This is actually raised power 8. So p, let me just take my eraser such as not to mess everything up. This is 8. Because this is n minus r, so 10 minus 2 should give me 8. Another thing you should observe is that you should note, so that you don't make mistakes, the sum of this should be 10. The sum is 10, something like that. Sum is 10, something like that. So p8, that is p raised power 8. Don't mind me, p8. Q raised power 2. So the best thing for me, I don't know, I can divide through by 270 if you don't mind. So let me just do that. 120 divided by 270, that is 4 over 9. So this will give me 4 out of 9. So this one is gone. That is 1 over 270 over 270. Okay. So I can retain this one, will be gone. Then this will be p. Can I just cut it? Cut this one. This is p. Okay. So I can write this one here, q square. Then this will be sorry about that. This here will be q. So this is 4 over 9 q. Sorry about that. 4 over 9 q equals p. So if you cross multiply now, do you need to cross multiply? I don't want to cross multiply. I think I like it like this because I have another equation now. I've been able to express p in terms of q. If I want to rewrite it, let me just rewrite it now. So here p equals to 4 over 9 q. I think I like it like this. 4 over 9 q. It's better like this. Yeah. So this will be my equation 2. Equation 2. Okay, I can put that also in a rectangular box. Okay, now from here now I can do something very interesting. Since I know that p times q is 1 and this is q, so I can go ahead and substitute for the value of in equation 1. Anywhere I see p, I can put 4 over 9. This is 4 over 9. Sometimes I write, my handwriting can be quite. This is 4 over 9, right? And this is q. Okay, I don't know, for some reason I can't be making this kind of mistake. Okay, P equals to 4 over 9 Q. I just rewrite this. Okay, so now so equation 1 now becomes let me just take this. So if you want to rewrite equation 1 in terms of P, so let's write equation 1 in terms of Q rather. So that will be Q. This is Q times P, and this is P here. So that's times 4 over 9Q. Equals 1. That is from equation 1. So from here we have 4 over 9Q squared Q squared equals 1. So Q squared will give you 9 over 4. That is inverse of over 9. That will be 9 over 4. And now this one asks us for positive constants. So Q will be square root of 9 over 4, and that will give you 3 over 2. So Q is 3 over 2. So let me put that also in rectangular box. Then let's go for P now. So P, sorry about that. Then P from here now, you know that P is P equals 4 over 9 from here, from equation 2 over 9 Q. So and I have Q to be 3 over 2, so times, sorry about that. Okay, 4 over 9 times Q, and we have Q already to be 3 over 2. 3 over 2. So that will be what? 2 here, 2, and this one here, 3. So I think I'm good, right? So finally I can just conclude that P is 2 over 3. Guys, so that is clear, guys. Okay, and that's pretty cool, and this is the end of this question. Let's just go ahead to the next question. Okay guys, here is the next question. Find the first three terms in the descending power of x in the expansion of x plus 2 over x squared all raised to the power of 6. And hence find the term independent of x in the expansion of 2 minus 4 over x cubed and all into x plus 2 over x squared raised to the power 6. Okay, yeah guys, let's get started with the first question. Guys, this question says that in the descending power of x. Okay, so meaning that if the first one here is 3 power 6, then it goes to 5, 4, 3, 2, like that. So it's the conventional expansion form, so no problem about that. Okay, at this point guys, I'm not sure I need to keep writing the general algebraic form. I think we should just go ahead and do what we've learned so far, guys. Okay, so guys, this is like your A, this is your B. Okay, so as this one decreases, this one increases. Okay, so I'm going to have n combination 0, definitely that is 1. So n combination 0, then this is the first term here, so x raised to the power of 6. Okay, then plus n combination 1, um n combination 1, then is descending power of x, so x goes to 5. That is the first term here. Okay, sorry about that. So this one goes to 5, and this next term goes to 1, because this one here is 0 here. So any 2 over x squared all this power 0 is 1 here, so it is multiplicative identity. That's why I ignored it. So here now I have 2 over x squared. Okay, so for some reason I'm not writing well. Okay, let me over x squared all raised to the power of 1. If you don't mind, let me just do that. Okay, then plus, I don't know why I put n combination 1 there for some reason. I know my n to be 6 already, so I don't know. This is actually 6, so I don't need to put n combination. It's actually 6 combination 1. Sorry about that. Then here now I have 6 combination 2. Okay, then x goes to 4. This is a first 3 term, so this is the first term, second term, so this is the third one. So I'm going to stop here. Okay, raised power 4. Then I have let me just open bracket for it. 2 over x squared. Okay, all squared. But I want the first 3 terms, so I think I'm good. Dot dot dot. So you can continue definitely like that. So what do we have here now? So that is x raised power 6. 6 combination 1 is 6. Guys, hope you know how to do this already. Okay, so 6 combination 1 is 6. So 6 times 2, that is 12. So I have 12. That is 6 combination 1 times 2, that is 12. So now this is x squared. X raised power 5 divided by x squared, that would be x3. Okay, x raised power 5 divided by x squared, that would be x indices, guys. Plus 6 combination 2. I need to use my calculator to confirm that. 6 combination 2, that is 15. Okay, so this is 6 combination 2 is 15. 15 times 4, because this is 2 squared, that is 4. So 15 times 4, let me just do 15 times 4, that is 60. So this is 60. And now this is x squared raised square. This x raised power 4. So x raised power 4 cancel this x raised power 4, so I'll be left with 60 here. So I think that's so, you can put 3 dots now. So that's what I have there. So the first 3 terms, so I'm good with this one. So the solution to this, I don't need to write it there. This is the solution to it. So let me put it in a rectangular box. I think it's too much. Okay, let's just put it like perfect. So that's the solution to the first question. This one is okay. So let's go ahead with the next one now. Now hence find the term independent of x in the expansion of this. Okay, now if you look at this, now this is s cube and this is s cube. So I think everything is pretty cool. So what I'm going to do now is just go ahead and write this here. 2 minus 4 over s cube then into this. Hope that is clear, guys. Now this x6, this will not be independent of x because there is no way you're going to do the division of this. But this one is pretty cool. So this is 2x raised power 3, that is cube 12. Is this 12? Yeah, it's 12 cube then plus 60. So we want the term independent of x. So term independent of x, I can have 2 against 60. Then I can have this one here against this. So this should give a constant value. So 20. This one will cut this one here. So I have 12 times 4. 12 times 4. That is 48. Minus 48. Because this one here, we cancel this one here. So you have minus 12 times 4. So 120. 120 minus 48. That is 72. So that's the solution to that. Guys, hope my 72 is pretty cool. Okay. So guys, this solution to this the term independent of x is 72, guys. So let's go ahead. Guys, here is the next question. Given that n is a positive integer, Find the first three term in the expansion of 1 plus half x all raised power n in ascending power of x. Okay, so let's just get started with this very first one first. Yeah, let me just go ahead and demarcate my board in order to manage my board effectively. Okay, so guys, now the first three terms in the expansion of this, guys, hope you are already familiar with how to complete binomial expansion using combination. Okay, so I have 1 plus half x all raised power of n. Now guys, I want the first three terms here, right? Okay, now don't forget that this one is multiplicative identity, so 1 raised power, given that n is a positive integer, it will still remain 1. That is multiplicative identity. But for the very first one, so 1 raised power n is 1, so let's just get started with that. So n combination 0, that is 1 too, so whatever the value of n is, so I have 1 plus, okay, I cannot go ahead with my n combination 1 now, n combination 1. Then as this one is decreasing, this one will be increasing, right? So I have half x raised to the power of 1 plus, then 1 raised power n minus etc, but it's not going to affect it. This one is like n raised power n minus 1, so it's not going to affect it. So I can just continue with the second term. So n combination 2, half x, that x is too big, don't mind me. Okay, half x, okay, then square. Then you continue like this indefinitely plus. But I want the first three terms, so this is the first term, second and third, so I'm cool like this, I'm okay. So I have 1 plus, guys, since you are familiar with how to do combination, so just go ahead and that will be n factorial over n minus 1, n minus 1 factorial, n minus 1 factorial, um 1 factorial, so that would be 1, so no problem about that. So into 1 over 2 x, then plus, for n combination 2 you have n factorial over n minus 2 factorial, then 2 factorial, and that will be x squared over 2. Let me just write it like that, or half x is okay like this, x squared over 2. Okay, if you don't mind, you can put this in brackets, plus, and we can just leave everything in school like this. Okay, so for this one, I don't know, let me just simplify it because I don't want factorial to be part of my answer. So this will give me 1 plus, so don't forget that this will give me n into n minus 1 factorial. Guys, hope you are good with combination already. I want to believe you have a very good knowledge, because there is no way we can um solve problem on binomial expansion if you don't have idea or pre-knowledge of combination. This is quite simple anyway, so you guys are advanced students, so I believe you are good, right? So and then I can also split this one into n. Okay, so this will be n into n minus 1, then n minus 2 factorial, n minus 2 factorial. Okay, so I'm good here now, so I can cancel that one. N minus 2 we go with n minus 2, n minus 2 factorial, then 2 factorial. So what I'm going to do here is, now I don't need to waste much time. 2 factorial is 2, 2 times 2 is 4, so I can have times s squared over 4 there. So that is clear, right? So that's pretty cool. So we can go ahead and cancel this one out. Okay, let me just take a line to strike it out. So n minus 2 factorial here, cut n minus 2 factorial here. Then you have n minus 1 factorial here, cut n minus 1 factorial here. So what do I have now? So I have 1. So this equals to 1. If you don't mind, you can just put this n here. I don't know, maybe n it, but yeah, you don't need to put it because this n will actually be the coefficient of x here. So if you don't mind, I will just put something like half n, because half times n, so I can have my coefficient now. Half n, sorry, n over 2. Hold on, I'm almost making a mistake already. Okay, because this is n times half, so that is n over 2. Okay, so this n over 2 will be coefficient of x. Is that clear? Okay, so that's pretty cool. Then this one, I don't know if I should open up. Do I need to open up? Okay. I'm not going to open this one up, guys, for now. I don't need to open it up for now. So let me just do n into n minus 1. Okay. So guys, this one here is n into n minus 1 over 4. So the coefficient of s square will be n into n minus 1 over 4, something like that. I think I'm good with this. In ascending power of x, so this is x raised power 1, this is x raised power 2, this is x raised power 0. So guys, I think I'm good. So let me just put that in a rectangular box. So this is the solution to the first one. Okay, so let's go ahead with the next question. Given that the coefficient of x squared in the expansion of 1 minus x into 1 plus 1 over 2x all raised power n is 25 over 4. Find the value of n. Okay, so mean that if I use this one to expand this one, then I should get 25 over 4. Okay, so guys, if you don't mind, let's just work in blue. So let's work in blue, guys. And I don't know if I should create more rectangular boxes. Let's just start here. And if this space is not enough, then I'm going to complete the same here. Okay, so let's go ahead and do that now. Okay, so what I have now is I have 1 minus x, okay, into this one here. So 1 plus n over 2 x. I don't know if I should open up now. I think I'm going to open up this one. And I don't know, for some reason I just put something like this and there's no operator in between this. Okay, because this is half raised power 1, so there should be plus here. So sorry about that. This is raised power 1, but it's uncalled for. But let's just, because I just want to confirm that it is actually in ascending power of x, so that's why. Okay, so let's continue now. X, then plus. I think I'm going to open up that place. So n to open up this one, I'm going to have n square. Don't let me open it up for now, so that I will not get you guys confused. So minus 1 over 4. Okay, x square. Okay, so this is the first three terms, so plus, I can just put 3 dots here. Okay. So now, guys, given that the coefficient of s square, so now the coefficient of s square, but let's use 1 to multiply. If we use 1 to multiply this, then this, so this will give us the first coefficient of s square. That is 1 times this will give us, that will be the coefficient of s square will be, this is the first coefficient of s square, because 1 is multiplicative identity. So the first part of the coefficient of s square is this n. I can open it up now. N square minus 1 over 4 x squared, provided you use 1 to multiply through. Then if I were to use x to multiply through, minus x better still. This will give me minus x, so that's not x squared. Then this will give me minus n over 2x squared. So the next coefficient of x squared will be n over 2. And if I still continue like this, this will give me cube. So this is not it. So now n squared minus n. So I see, I almost made a mistake here. Sorry about that. This is n squared. I'm not sure this is the best. I don't know if I should have I don't need to do that anyway. So the first coefficient of x, this is when you use 1 to multiply through, I have n squared minus n over 4. Then when you use x minus x to multiply through, you have minus n over 2. So I have the coefficient of x squared now. So, and this said the coefficient of x squared equals to, so this one equals to 25 over 4. 25 over 4. So at this, from here I can go ahead and find my LCM. Let me use line. So LCM here is 4. Okay, because I have n squared minus n over 4. Oh, sorry about that, guys. Okay, I did something wrong here. These 2 factorial for some reason, I don't know why. I just sorry about that. This is n minus 2 factorial here, then 2 factorial. So for some reason I just omitted it. So thank God I'm on blue, so I'm going to effect the changes with blue here. So this one remaining 2 factorial here. This 2 factorial is missing here. Okay, don't forget that this is okay, I think I did this one already 4. Okay, another thing now is, see, a lot of mistake. I'm sorry about that. This is square. So this is x square and 2 square is 4. So this is actually 4. Okay. Do you understand now? This is x square and this is half square. So this is actually 4. So if you don't mind, I will just do 2 factorial. This is 2 times 4. So 8. So I can put my 8 here now. So this is actually 8. So sorry about that. So this is 8. Okay. So 2 times 4 is 8. This is 8 here. So so this should give me n squared minus n over 8. So let me just take my eraser. So guys, this is video. So you have to be careful and just follow. True. Okay, so this is actually 8. Okay guys, hope that is clear because this is actually half x squared. So half x squared will give me x squared over 4. Okay, so 2 factorial times 4, that is 8. So every other thing is okay. So LCM here is 8, right? So 8 in this, so I'll have n squared minus n. Then 2 in this is 4, so this is times 4. So that will be minus 4 n. Then equals to 25 over 4. Okay guys, if you don't mind, if you cross multiply, better still, 2 year, 4 year 1, 4 year 2. You guys are hard math students, so you understand this, right? If you like, you can cross multiply, and so it's going to cancel out. Or better still, just multiply by 2 or something. Okay, so now what do I have here now? I have n squared. So minus n minus 4n, that is minus 5n. Now this one, if you cross multiply, this will be equal to 50. Bring 50 back, that will be minus 50. Minus 50. So like I equate it to 0, it's like it's a trinomial equation now. So our quadratic equation, so I can solve now. So nn, I want product of 50, this one, so this will be minus 10 times 5. So that I cross this one, this will be minus 10 plus, so this is correct. So if you factorize this one now, you're going to have something like n minus 10. If you expand n minus 10 into n plus 5, that should give you that trinomial equation here. So you can confirm that, guys. So equals to 0. So I can conclude that n equals to 10 or n equals to minus 5. So now, but this is going to be this positive integer, okay? Where n is a positive integer. So the only solution will be n equals to 10. Because this second one here will give you n plus 5 equals to 0. That will give you minus 5. So the solution there is n equals to 10. So, and that is the solution to this question, guys. So n equals to 10. And the solution to the first one is 1 plus n over 2x plus n into n minus 1 over 8x squared. So guys, let's go to the next question. Here is the next question. The first three terms in the expansion of 2 minus 5x all raised to the power of 6 in ascending power of x are p plus qs plus rx squared. Find the value of each of the integers and p, q, and r. So let me go ahead and demarcate my board and complete the task accordingly. Okay guys, don't forget that this is ascending power of x. Okay, so let's get started with this now. So using combination, right? So the first term there is x, sorry, 2, and the second part is 5x. So as 2 is decreasing, 5x will be increasing, raised power of 6. But actually I want the first three terms, right? The first three terms. So let's get started now. So I'll start with n combination 0, that will be 1, then 2 raised power 6 plus 6 combination 1. This is 6 combination 0, guys. So 6 combination 1, then 2 goes to 2 raised power 5, then this term will go to 1, so that's minus 5x. Guys, don't forget the operator behind it. Minus 5x raised power 1, then plus 6 combination 2. I don't know, I need to write my 6 very well. 6 combination 2, okay, then 2 goes to 4, 2 raised power 4, 2 raised power 4, and then minus 5x squared, all squared, so that I don't make that kind of mistake again. That's like the last question. Okay, so now I have the first three terms now, 1, 2, 3. So I have 2 raised power 6. I need to use my calculator at this point, okay, guys. So 2 raised to the power of 6, and that is 64. So that is 64. Okay, guys, don't forget this is minus, okay? So definitely, so minus, this will be minus here. So 6 combination 1 is 6, so 6 times 2 raised power 5 times minus 5. Okay, this is 2 raised power of 5. Okay, let me just start again. 6 combination 1, that is 6 times 2 raised power 5, then times minus 5. So that is 960. So minus 960. Guys, make sure you confirm everything. Just use your calculator. 960 x, then plus 6 combination 2 times 2 raised power 4 times 25. So 6 shift combination 2 times 2 raised to the power of 4, then times 25. Okay, so that is 6,000. So this is actually 25 minus 5 squared is 25. Okay, so that is 6,000 x squared. 6,000 x squared. So I'm good with this now. Okay, and this is find the value of, okay, so if you compare this with this now with p, I don't know, let me just go ahead. P plus qx plus rx squared. So you compare the constant value, the coefficient of x and x squared, then we can conclude that let me put it in a rectangular box now. So we can conclude, okay, I don't like that. So can you put it here? Okay, so then now we have in conclusion, value for p is 64. My handwriting. So p is 64. Okay, p is 64. Guys, hope that is clear. P is 64. Q is minus 960, and my R will be 6,000. I don't know, for some reason. I just need to write outside the, I can't just waste more time. Okay, so that's cool. I need not to put this one in rectangular box, guys. I'm cool there. So let me just go ahead and demarcate and go to the next question. If you don't mind, we can change the color. I like to work in blue. Yeah, why blue? Hello, why do you like it blue? I'm sorry, guys. I just like what? I'm playing already. Okay, so here now just I'm try to complete the remaining question here. If that rectangular box is not enough, then I'll go ahead and finish up here. Okay, so now the next question, in the expansion of 2 minus 5x all raised power 6 into a plus bx all raised power 3, the constant term is equal to 512. Wow. And the coefficient of x is 0. Okay, so find the value of each of the constants a and b. Okay guys, I think the best thing for me to do now, since I have this already, I have 2 minus 5x raised power 6. I have the first three terms here. So let me just go ahead and work with this one. Guys, and now, because this will be the last section of the video, now let me just go ahead and use Pascal Triangle this time around, because I've been using combination. So let me introduce guys to Pascal Triangle. 1, 2, 1. So 1, 3, 3, 1, guys. Hope you know. I don't want to use combination for that, okay? Just to make it pretty cool. So this will be the coefficient now. So if you want to expand this one now, so you take the first coefficient constant value 1, so that is 1 times a, that is a. Let me just write what I want to do. A plus bx. Okay, I don't know if I should. Hope my stuff is not lagging already. Okay, raised to the power of 3. Okay, so now, so this as a is decreasing, then this will be increasing. So the first, you assign a the first power, so times 1. So that is a raised to power 3. Okay, plus, then the next term is 3. So 3, then a square, your a will be reducing, then bx, let me just put it together, bx raised power 1. So I don't need to put raised power 1 there. Then plus, the next constant value is 3, then a raised power 1, then bx square, all square, then plus, then a goes to 0, a times 1, that's so a raised power 0, 1 times 1 is 1, then bx all raised power 3. Let me just write it here. Okay, sorry about that. Bx all raised to the power of 3. So what do I have here now? Okay, so let me just write this here now. I don't know. Yeah, let's just do that. I think I'll just go ahead and put this one up and this one down. Okay, so I want to multiply with this. This is what I have here. 64. 64 minus 960 x plus 6000 x squared. So I multiply this one into this. So I'll just write the second one down. I don't want to write this sideways so that I can compare easily. So this one into this one here now. So this is what I have here now. A raised to the power of 3 plus 3a squared. Yeah, I think it's good. 3a squared bx plus 3a b squared. This is b squared x squared. So that is b squared x squared. Okay, bx x squared, then plus b raised power of 3, then x cubed. Okay, so now if I want to multiply now based on the information given by the examiner, the constant term is equal to 512. So where is the constant term here? For example, if I want to use 64 to multiply through here, so the only constant term I'm going to have is 64 times 683. So I can have this one now. So 64 a raised power 3. I don't want to write this like that. I don't know. I'm just so okay. 64. Sorry about that. A raised to the power of 3 equals to 512, because that's the only constant term that you can have. 512. So I can tag this one equation 1 if you don't mind. And in fact, I think I can just finish up here. From here, I can find the value of a. So a will be cube root of, yeah, I think I don't need to tag. Let me tag it equation 1 anyway. So from equation 1 also, from equation 1, a will be cube root of 512 over 64. 512 divided by 64. So let me use my calculator and get that. So I think I'll put my final answer in rectangular box. So let me put a answer here. So cube root shift cube root 3 512, right? 512 over 64. That is 2. So the value of a here is 2. So okay, sorry about that. So the first question, because I'm find the value of each of the constants. So the first one, why am I like this? Sorry about that. So can you take out pen? So a equals to 2. Okay, I'm just very fortunate that a can easily come out like this. Now, then, and the coefficient of x. So now, the coefficient of x now. For example, if I want to use 64 to multiply this one through again, so this will not give me coefficient of x. So the only one is, because this will give me x squared, this will give me x cubed. So 64 times 3, a squared b x. So that's what I'm going to have. 64 times 3. So let me do that now. 64 times 3. That is 192. So that's if I want to use 64 to multiply through here. So that is 192. 192. So that's 64 times this. A square b. A square b. Then x. So that's the coefficient of x. So that one is confirmed. So that's the first coefficient of x. Then if I want to use okay, if I use 64 to multiply through, this is the only one I'm going to have. Okay, what about if I want to use a to multiply through here? A, this constant value here. Okay, so if I want to use a to multiply through, this will be the only one I have. So that will be 960x. So this one here, with this another, so 968 cube. 968 cube, right? So, and this is minus. So minus 960 a cube x. So that will be the next coefficient of x. I'm not sure I can get any other coefficient of x. That's all. Because this will give me square. That's all. So this is now, okay, equals to what? 0. Interesting. Okay, from here now I can just go ahead and, if you don't mind, yeah. Yeah, I can reduce this one. This is a square. Okay. Don't let me do that now. So I can do 192 a square b equals to, take that one there, that is 960 a cube. So if I divide both sides by a square, so this will be gone. So sorry, we have to continue from here. Guys, sorry about that. This one here, I want to take this line. So this a square, this is a square, cancel out a cube here, so I'll be left with a here. So I actually want to take this line before, and yes, okay, so take this one here. So I'll continue here like this now. So from here now I have 192b 192, and in order to make this so that I don't um mess up everything, let me just put the last part in rectangular box from here. So okay, so 192b now, 192b equals 960. Now don't forget that this is a square, this is a cube, so this one cut here, this is a, so that is 960a. And what is the value of a? A is 2. Okay, so I can conclude that b it'll be 960 times 2 divided by 192. Yeah, let me just put that. So what is 960 times 2? 960 times 2, that is 1920. 1920 divided by 192. So you can see that if we take this one off here, 1. So B is 10. So finally, I can conclude that the value of B is 10. Let me just put it in a rectangular box. Okay, so the value of B is 10. So guys, this is the end of this tutorial, guys. Section, guys, don't go away, guys. I need to show you something. Calm down, guys. Just hold on, guys. Let me show you something very quick. Okay guys, here is my YouTube channel. Immediately after this session, I'll make the video on polynomial expansion available via my YouTube channel, guys. So guys, there are quite good numbers of videos that will help you guys enhance your learning. Quite good numbers of video in mathematics, additional mathematics, ICT, robotics, and coding that will actually help you guys enhance your learning. So for example, you can see something like transformation, 2 rotation, this IGCSE exam style question, solving polygon, creating artificial intelligence using scratch programming. You can develop AI using Python programming, develop your own games, something like Legend of the Fire Lord using Scratch or MBlock. This is vectors, GCSE. You can create a math quiz and graph of trig functions, simulating binomial distribution, permutation and combination. Quite good numbers of videos, ICT like database reports and data manipulation, website authoring, document production, mail match presentation, and many more, guys. Okay, if you find any of my video quite useful and helpful, guys, you can just go ahead and click like, and also subscribe to my channel for updates on new video. And here is my test shop also. Unlike my YouTube channel, there are quite good numbers of e-learning resources like board works, um, um, worksheets, okay, and all videos that you can have access to via my YouTube channel are also available on my test shop. Okay, so ICT, mathematics, additional mathematics, robotic and coding video. You can see something like statistics and probability part 1 and 2, complete board work and video on how to solve polygons, matrices and determinants, and geometry and measure, application of calculus, creating artificial intelligence, and many more. Guys, if you find any of my e-learning resources also useful, go ahead and help review, and just go ahead and enjoy yourself, guys, and do have a great day ahead, and I wish you the best. Okay, so happy day ahead, guys. Bye. Okay, let's end with this note, guys. Let's end with this note.
Wake the streets up.